so let's see. So on the first one, and the names make it difficult too. All right, I'm going to say that that's Mateus. I'm not sure. Looks up at a certain time of day and sees that the sun is at an angle of 32 degrees with the horizontal. So that means here's the sun up here. He has to look up 32 degrees to see the sun. Okay, so if he's approximately 6 feet tall, how long is his shadow? So he's going to stand like right here, where the sun's behind him, and it's going to cast a shadow here on the ground. And this is what we're looking for, is how long is his shadow?
Oh, I thought it was like at the bottom, like at the end of the...
No. So he's 6 feet tall. His shadow's here on the ground. The sun has to be behind him so that his shadow gets cast out in front of him. So we have this triangle here. I'm going to redraw it so you can see a little bit better. Where this is what we're looking for. This is 6, and then we know this angle in here is 32 degrees. So we can use SOHCAHTOA to solve this triangle, to find that side that we're missing. So if we look, we have this angle. We have the side opposite. We're looking for adjacent. That's tangent. So the tangent of 32 degrees equals 6 over x. Opposite over adjacent. And remember, if the x is on the bottom, we have to switch. So it's 6 divided by the tangent of 32 degrees. So make sure your calculator's in degree mode. Degree mode will also work. 6 divided by the tangent of 32. 9.6 D. So just remember that a shadow problem, the person has to be between the sun and their shadow. The sun has to be behind the person to make a shadow like that. Okay. Here's another name. Atala is trying to figure out the height of her building and the building next, or figure out how the height of her building and the building next door compare. She knows that if she stands at the edge of the roof of her building closest to the building next door and looks up at the roof of the building next door, she must look up at an angle of 13 degrees. So here's her building. The building next door has to be taller if she's looking up to see the top of it. So if she stands right here at the edge to look up to the top of the building right here, this is 13 degrees. If she stands at the base of her building, closest to the building next door, and looks up at the roof of the building next door, so now she's looking up from here, she has to look up at an angle of 72 degrees. So this is 72 degrees. If she knows that the building next door is 800 feet tall, approximately how much shorter in feet is her building than the building next door? So we're looking for this distance here. The distance that her building is above the other building. The problem is that that is one side of this triangle up here, and the only other thing we know about that triangle right now is the angle. And you need at least 2 pieces of information to use SOHCAHTOA. So that's why they gave you this other bit of information, because in this other triangle, you do have 2 pieces of information. And you can use those 2 pieces to find this distance right here. And that will be the same distance up here. Once you know that distance, then you can find what you're looking for. So this is actually 2 problems in one. So to find this, I'm going to use tangent again. I've got the tangent of 72 is opposite over adjacent. So once again, you'll have to divide 800 by the tangent of 72. So this distance in here is about 260 feet if you round it. So the buildings are about 260 feet apart. And so once you know that, now you can come up to this other triangle. And in this triangle, you've got the tangent of 13 degrees is opposite over, we just found the adjacent was 260. So you'll multiply now to get x. 260 times the tangent of 13. Or I've got my answer up there. That's the last thing I got. So I'm just going to type times tangent 13, 60. So approximately 60 feet is the difference. So that one's pretty tricky. All right. And the last one, another name. Petra watches a plane flying overhead at a constant altitude of 26,400 feet. When she first looks up at the plane, she sees it at an angle of 50 degrees above the horizontal. So here's the airplane when she first spots it. It's 26,400 feet above the ground. She has to look up at an angle of 50 degrees to see it. 5 minutes later, she looks up and she sees the plane. Actually, the plane has to be going that way. We'll say it's flying backwards. 5 minutes later, she looks up and she sees the plane now at an angle of 7.85 degrees. So it's traveled pretty far just in 5 minutes because the angle that she has to look up has greatly decreased. It's still flying at the same altitude, though, so it's still 26,400 feet. But now the angle she has to look up is 7.85 degrees. All right, so approximately how fast is the plane traveling in miles per hour? So we know that it went, what we need to do is we need to figure out what distance did it go in those 5 minutes, and then we can translate that into a speed. So what you're going to do is you're going to figure out how far was the plane from her when she first saw it, and then how far was it when she saw it the second time. What's the difference between those? That'll tell you how far it went in 5 minutes, and then you can translate that to miles per hour. All right, so both of these are going to use tangent, right? We're going to have the tangent of 50 equals 26,400 over x, and the tangent of 7.85 equals 26,400 over y. So for both of them, you're going to divide 26,400 by the tangent of the angle. So I'm just going to do this one real quick. So let's see. 26,400 divided by tan 50. That's how far the plane was from her when she first saw it. And then 26,400 divided by the tangent of 7.85. That's how far away it was when she saw it the second time. So if you subtract those, you could figure out how far apart, or how far it went in 5 minutes. So I'm just going to say 19,142 minus 22152. It went 169,330 feet in 5 minutes. So 169,330 feet in 5 minutes. So then you can change that to miles per hour, right? So there are 12 5 minutes at an hour. So it's going to go this distance 12 times at an hour. So if you multiply by 12, that's how many feet it would go in an hour. And then if you divide by 5280 for how many feet are in a mile, it's about 384 point, I got 0.8, they've got 0.7, but pretty close.
Wait.
Miles per hour.
Okay, I lost you after you did the two tangents or whatever.
Did you subtract and get the distance that they went?
Yeah, it came to like a negative number. Negative 169,329.
Yeah, that's fine. Just take the negative off.
Oh, okay, and then divide that by 5280.
And divide that by 5280 and then multiply it by 12.
Multiply by 12.
Yeah, because that's how far it went in 5 minutes, but you want miles per hour. So you've got to change minutes, right, to hours. And then you've also got to change feet to miles.
Dang.
Yeah. There's a reason that it was under the hard.
Yeah, I leave those blank.
Me too.
All right, so the good thing is we only have one thing left in this one, and so there's one other little thing that I